Okay, so in video 1 we did step 1, which is calculating the magnitudes of E1 and E2. Now, to be able to add them, you need to pay attention that they are vectors. And as you can see in the sketch, in the graph, they are not perpendicular. If they were perpendicular, for example, E1 and E2, this way, okay, we will simply apply the Pythagorean theorem. But here in the problem, they are not perpendicular, as you can see. So I need to refer to what I learned in physics 1, how to add neither vectors or non-perpendicular vectors, if you remember. The first step is that you need to resolve E1 to EX, E1X, and E1Y. And you need to resolve E2 to E2X and E2Y. So let me take E1 and see how will we resolve it. E1, the angle that it makes with the positive x-axis, if I go to point P and imagine that I have a positive x-axis, the angle that E1 makes with the positive x-axis is simply 90. Okay, so E1x will be E1 cosine 90, while E1y will be E1 sine 90. Substituting the value of E1 here and using your calculators, you will find that E1x is just 0 Newton per coulomb, while E1y is the same number. Sine 90 is 1, so 5 times 10 to the power of 5 Newton per coulomb. The same steps will be done for E2. I need to find theta from the positive x-axis for E2. Now, as you can see, the angle between the positive x-axis and E2 is a big angle, almost a circle, but not complete circle. If we cross from here to the y-axis, it's 90. To the negative x-axis, the angle is 180, it's half a circle. Till here, again, 90, one more 90, so 270. So from here till here, it is 270 degrees. What's left to find the angle from the positive x-axis? This part inside the triangle. Let me name it alpha. So the angle between this vector, E2, and the positive x-axis is this green angle. It has two parts, 270 plus alpha. So my job is on the side here, down, I will say how to find alpha. Alpha actually can be found using the tangent function, tan theta. So tan alpha is the tan function is the opposite over the adjacent. So if I want to find alpha, I will apply tan inverse, the opposite, which is 0.45, the opposite side, divided by the adjacent side, 0.3. Okay, so alpha can be found using this formula. If you find it, you will see that it is 56.31 degrees. Okay, now we will add the 270 to this number, 270 plus 56.31. So we will find that the angle between the positive x-axis and E2, be careful that we all the time go counterclockwise, is 326.3 degrees. Now we will be resolving E2x and E2y. For E2x, I will say it is E2 cosine this number, and for E2y, it will be E2 sine the same angle. Using the value of E2 and your calculators, you will find that this equation, E2x, will give me 1.28 times 10 to the power of 5 Newton per Coulomb, while this line, this equation will give me negative 8.5 times 10 to the power of 4 Newton per Coulomb. Okay, I hope that you are solving with me the steps and recording them. In the next video, we will continue the third part of our problem.